Okay, so for question 6, we've got a question on the normal distribution. So I would always start a question like this with just a bell-shaped curve. And my apologies, my baby is in the background trying to make a little bit of noise and attract me. Okay, so we know that here we've got a mean, which is unknown. And we know that 3 out of every 4 sessions take more than 80 minutes to complete. So 80 minutes must be to the left-hand side of here. So that's my 80. And here, this is my 3 out of 4. So my area to the right of 80 must be 0.75. So I can say that the probability that x is greater than 80 equals 0.75, and remembering that we're always looking at the left hand side of the distribution, I'm going to change that to the probability that x is less than 80 must equal 0.25. So we're going to standardise it because we don't know what mean is, so we can't read straight for our calculators yet. So I can say that the probability that z is less than 80 minus mu over sigma equals 0.25, and then I'm going to need to use the inverse normal distribution. So I can say that 80 minus mu over sigma is the inverse normal of 0.25. So let's just have a look at what that looks like. So on my calculator, I'm going for my inverse normal. So menu 7 takes me to my distributions. I'm looking at the inverse normal. My area is 0.25. It's the standard normal because I've standardised up here. So sigma and mu, as they are there, is minus 0.674489579. I'm going to keep that with a reasonable degree of accuracy because I'm going to need to calculate it, and I'm going to need to calculate with that in a second. We know that sigma is given in the question. It's sigma's 18. So I can say 80 minus mu equals 18 times minus 0.6744 ... Rearrange that, bring the mu to the right hand side, bring this to the left hand side, and I get 80 plus 18 times 0.6744 equals mu. So let's just put that into our calculators. 80 plus 18 times 0.674489579 gives me mu equals 92.14 mins, 92 to nearest minute. Part B and C become considerably easier because we can just use our calculator more intensively for those. So part B, probability that lasts more than 2 hours, so the probability that x is greater than 120. So on my calculator, I'm now going to the normal CD. Remember, I never use normal PD. My lower bound is 120. My upper bound needs to be something large, so I'm just going to put in lots of 9s. My sigma I know is 18. My mu is 92.14, and it tells me my probability is 6.08%, or 0.0608. For part C, this is asking probability that x is, it needs to be greater than 2 hours, but less than 2.25 hours, given that we know that it was greater than 2 hours. I'm going to just turn that into minutes. So it's probability that x is greater than 120, but less than 135, given that it was greater than 120. So I know here I'm going to be dividing by 0.0608 379. Okay, so I'm going to be dividing by that because that's what I worked out in part B. Probability that x is between 120 and 135. Let's go back to menu 7, normal CD, lower bound is 120, lower bound to 120, upper bound to 135, sigma is 18, and it gives me 0.05221. All I now need to do is do that division. And it gives me 0.858.